Let's have a look at the differences between consecutive terms. -1 minus -5 gives us 4. So between the first two terms we have a difference of 4. 3 minus -1 also gives us a difference of 4. 7 minus 3 gives us 4, and 11 minus 7 gives us 4. Because we have a constant difference between consecutive terms, we call such a sequence an arithmetic sequence. The general formula for the value of a term in an arithmetic sequence at position n is given by a plus in brackets n minus 1 d. Let's have a look at the meaning of each one of these variables. Tn refers to the value of the term at position n in the sequence. A is the same as T1, so A will be the first term. N is the position of the term in the sequence. And the new variable D refers to the constant difference between consecutive terms. Determine the general term. So let's use this formula and apply it to our sequence that we have here. We must find the values of A and D. We know that A is the first term, so that will be -5, and by now we know that the constant difference is 4. So now we can say that the term in position n will equal -5 plus n minus 1 times the constant difference 4. This simplifies to Tn equals 4n minus 9. If we now want the value of a term in any position, we can merely substitute the position in the place of n and then calculate the value of the term. Determine the 10th term. So we are looking for T10. That's the value of the term in position 10, and this will be 4 times 10 minus 9, which is equal to 31. This means that the term in position 10 has a value of 31. Which term equals 395? So now we know the value of term number n, which is given by 4 times n minus 9. We know that Tn equals 395, but we don't know its position. So we can use our general term formula and write down 395 instead of Tn, and that will equal 4 times n, its position, minus 9. Simplifying this, I get that n equals 101. This of course means that where the term has a value of 395, it lies in position 101. An alternative way of doing this would of course be to expand this sequence until you get to the term whose value is 395. And then you start counting from term 1 until you get to term number 101. So it's definitely easier to use the formula, and in the exam you are forced to use this formula. The third term of an arithmetic sequence is 12, and the 12th term is -24. Let's analyze the information given to us carefully before we start this question. Here it says that the third term of an arithmetic sequence is 12. The word arithmetic sequence is important here. They've given us that T3 is equal to 12, and we also know that term 12 is equal to -24. And the fact that it's an arithmetic sequence means we must use this formula. Make sure that you know what the difference is between the 12 in this first equation and the 12 in this second equation. In this first case, 12 is the value of the term. In the second case, 12 is the position of the term that has a value of -24. Determine the sequence, so we must find the first 3 terms of this sequence. What do we know? We know that term 3 has a value of 12. So our third term from the formula will be a plus 2d equals 12. And the 12th term, the general formula, will be a plus 11d, and that will equal -24. Make sure you know why it's a plus 2d, because the third term will be a plus n minus 1, and n is 3 in this case, so 3 minus 1 is 2d. The 10th term, for example, will be a plus 9d, and the 100th term will be a plus 99d. So now if we go back to these two equations, we have two unknowns, two equations, and from these we can solve for a and d easily. One way to solve this simultaneously is to subtract equation 1 from equation 2, because that eliminates the a values. Then we have 11d minus 2d gives me 9d, and minus 24 minus 12 gives me minus 36, and therefore d will be minus 4. This value of d equals minus 4 I can substitute into any of these two equations and get a final value for a. If we substitute d as minus 4 in the first equation, then I get a plus minus 8 equals 12, and I get a being 20. Now we've established that the value of the first term is 20. How do we find the value of the second term? We must add minus 4 to the first term, and that gives us 16. And then the third term will be minus 4 plus 16, which gives us 12. And so we continue with the sequence. Determine the 20th term in this sequence. Here we have the formula for term number n. So in this question I know that I want to find the value of the term in the 20th position. So n must be 20. I do have values for a and d. So if we substitute 20 for n, then t20 is 20 plus 19, which is n minus 1. And we multiply this with the constant difference, which is minus 4. Make sure that you know the difference in meaning between this 20 and this 20 that we have here. This one is the value of the first term, and this 20 indicates the position of the term whose value we are looking for. When we simplify this equation, we get the value of term at position 20 as minus 56. Determine which term is the first negative term. Negative, of course, means smaller than 0, and we want to determine the position of the first negative term, or the first term that is smaller than 0. So Tn must be smaller than 0, and out of this inequality we will solve for n to find out which term in the sequence is the first one that is smaller than 0. Why will we get terms that are smaller than 0? Well, because d is negative, and if you look at this sequence, you can see that the terms become smaller and smaller. To calculate Tn then, I use the formula above, and a is 20, n is the unknown value that I'm looking for, and d is minus 4. In solving this inequality, you must remember in this step that we are dividing by a negative value, a negative 4, and then our inequality sign must swap around. So n must be bigger than 6 for terms to be negative. So n must be bigger than 6 to ensure that terms are negative. So all terms where n is bigger than 6 will therefore be negative. So which will be the first negative term? It will be term number 7.